looking into this thing, speed v plot speed v and time period t for a circular orbit. Circular. So LEO is low Earth orbit. Okay. As a low Earth orbit, function of altitude z. Any ideas? Try to pay attention rather than taking notes. You can take a picture and make your notes later. I want to know if you guys are studying and if you guys, how are you guys going to fare in the exam tomorrow?
Dr. Zoom, that says altitude z degree.
Z, question mark.
Oh,
So you have altitude z on the x-axis. How will the speed vary?
You give us that one equation where it's like the change of the area over time when you had different R's. Can you use that? It was like D.
Now this is based on your understanding until now. This is Z, this is V, this is Z. Simplest of problems, okay? T. Anybody? Plot. How will the plot look?
Wouldn't the speed be the same all around?
It'd be
Altitude.
With altitude?
The altitude is varying, it's increasing.
Also, the altitude is increasing, then the velocity would,
The speed.
shouldn't it just be a straight line at an angle?
Okay. So this will be. This will be. Get it?
What's the one on the left? That's
Time period. So as we go above and above, this is the altitude. Okay. The time period of the orbit increases. Right? The speed decreases. Okay.
you shouldn't just see decreases. Okay, never mind.
What you learned something about this.
No, I will look at the graph wrong. It's alright.
This is P, right? This is P. Okay, this is A. What do you know about speed here? Speed here.
Yeah, P is the fastest.
Fastest, right? So as the altitude becomes more and more, the speed decreases.
This is for a circular though, right?
Right, so here it is. This is not for one orbit. You understand? This is for as the altitude increases. So if you take this circular orbit, this circular orbit, this circular orbit.
Also, the altitude is stated to be increasing.
Right. So that's what this plot says. Okay. So here the speed will be more, less, lesser.
Oh, there's a, and there's a, just, they use the equations and then the time period and the velocity equations. And then they come up with the graph. You can also do
Speed.
that
You have to be distinguish between speed and velocity. Okay.
Will be, okay, so speed.
Hmm.
They use the speed and time period equations.
Mm-hmm.
And they just plug in, they plug in numbers so you can get a, idea of what the graphs look like. You can also do that too, right?
You can do that. Yeah. Okay. You should see, ultimately, if you want to use the equations, how are you don't want to plug in numbers. Circular orbit, right? How do you correlate these two?
As altitude increases speed.
What expression are you going to use?
There,
Hmm?
it's R for Z. It's
Right, but what that is correct. You're going to use simply this. We have done this. V circular is equal to what?
Square root of mu of r.
Mm-hmm. So it is
it's a square root of mu of R.
square root of mu over
R.
r, right? That's what
There shouldn't be
1 over square root of r, correct?
Right.
So do you see this is v square is inversely proportional to 1 over r. You see that? So r is what?
Yes. Your altitude is U. RE plus
This will always be constant, right?
Right.
So if this increases, this increases, this increases. So if this increases, what happens to this? Decreases. You see? Okay. And what is the time period? T is
T pi
2 pi over square root of mu. Right? This is T square A cube, right? Right? This for circle, what is this? 2 pi over root mu r cube. Right? So, if this increases, what happens to this? Huh?
Which one? Mu? Oh, it's not decrease.
Mu will not increase.
If R, if you're saying if R increases,
Hmm.
then your time period should increase. Or does it increase?
No, it's not. No, it should increase.
It should increase. T square is proportional to r cube.
Yeah.
It will increase. This is the okay. Example 2.5. Calculate the altitude and speed of a geostationary satellite. How are you going to? What all information is embedded in this? Before we solve the problem, I might ask you a question like this. What all information from the statement of example 2.5? So listen to this carefully. Calculate the altitude z geo and speed v geo of a geostationary Earth satellite.
So you know it's geostationary.
Yes. So what do you know about a geostationary satellite?
Circular.
It's circular. Yes. What else do you know?
Orbits around the Earth. Speed.
Geo means Earth. Yes. It's orbit. Even if there is no Earth there, geo means Earth. Geo refers to Earth. Helio refers to sun. Okay. Lunar refers to. You understand?
Move at the same speed as the Earth stationary.
It doesn't move.
It's stationary. It rotates.
Relatively stationary. So what is the orbital period of a
24 hours.
24 hours? You get it?
So
This T is 24 hours. Or it has to be in If you want to do calculations, it has to be in seconds. What will this give you? What is this mu? Mu of Earth. So this you can find, since this is a circular orbit, geostationary orbit is a circular orbit, this R will give you the radius. If you minus this out of that, what are you going to get? Altitude. You get it? Velocity is again simply this. You should immediately know that if it's a geostationary, circular orbit, 24 hours orbital period.
You said it was the last 24 hours?
Orbital period.
Okay.
It takes 24 hours, right? So what's happening is, when Earth is rotating, the orbiting body is also rotating. It's orbiting at that rate, 24 hours per day. So it's a geostationary.
What you said you have to subtract out though?
Huh?
What did you say you said to subtract out for all?
If you are asked altitude, this is altitude, this is the radius, this is the radius of the Earth. Okay? So most of the times, you should know the difference between altitude and the distance. Okay? Distance from the center.
So you was trying to subtract the distance from the radius of the Earth to find.
Right, yeah.
Okay.
One more example. See if you can follow this example. Okay, this is a very, very vital example. I think if you are able to do this, you would have studied well.
For example, this is
Example 2.7 without much help. Okay. Pay attention here. No singing. I'm going to read out the problem. An Earth satellite is in an orbit with a perigee altitude of 400 kilometers and an apogee altitude of 4,000 kilometers. Find each of the following. Okay. Now, find each of the. Before I say find each of the following, if I tell you in exam, draw this orbit and label the following parameters. Can you do that?
Yeah.
ZP is equal to 400 kilometers. ZA is 4,000 kilometers. Draw the orbit. Okay. I'll change the question a little bit. What is the range of E? No, you don't have to. Just tell me what is the range of E.
0 to 1, 0.
Yes. Do you need to calculate anything if you are asked the range? If I ask you the range, you're going to be smart and just give me 0 to 1. If I ask you compute E or what is the value of E, you're going to compute. Okay?
But also in the problem statement, when you ask for just the range, you also give us what the orbit is.
If I give you that, does it make sense what orbit it is? It has to make sense to you what orbit it is. Okay. If I ask you what is the range of total mechanical energy?
0.
Is it? So you lost points. You lost points. What is the range of that total mechanical energy?
Less than
Less than 1? You lost points.
Less than zero.
Less than 0.
Oh, and
What orbit is this?
That's what the you got the periapsis. Larger than
Oh, yeah.
Yeah, your periapsis is the distance from the Earth.
but yeah, what that was larger than this.
Periapsis is the shortest distance.
The shortest one?
Yep.
Okay. Now, if I ask you to draw, you're simply going to say you're going to do this, right? What is this distance? How much is this distance? Huh?
It's A.
Oh, that's it. Z.
That's RP.
Is it?
Yes, sir.
What is it?
Z.
Hmm?
RP. In this case or in general? Z.
In general.
Oh, yeah.
What is this distance?
Alright. I would never see that.
Trick question.
Yeah, I thought the way you were drawing it, I couldn't see.
That's nothing.
This is also RP. The distance, I'm asking you the distance.
It's not, it's equal.
This has to be equal to this.
Mm.
Okay.
Do we have to draw?
What is this?
From F to A is R.
Alright.
RA, right? What is this? How much is this? Anybody?
He said it's 4,000.
Is it 4,000?
Plus Z.
That's what you put on
Or
board.
plus RE.
If you give 4,000, what are you going to get?
Minus points.
Anthony has said, okay, he has stocked for all of you. This is 400 plus RE. If this is a Earth orbit, okay?
He said vertical.
Define E. Trick question.
Eccentricity?
Just write the equation.
You're saying define what E is? E?
In words, define E.
What? Just square root of 1 minus b squared over
What do you know E is?
R.
ZA
minus
ZP over ZA plus ZP.
Oh, there is another equation.
RA minus RP over RA plus RP. So
In words. Yeah.
That is what you know is the formula, right? How do you say it in words? It's the ratio of the distance, it's the ratio between the foci.
is the ratio between the both.
This is the distance between the foci, right? RA minus RP is this distance, right?
Yeah.
Divided by the,
You also said the shape of the orbit too, right?
huh?
You said it's the shape of the orbit.
So that is not, that is what is the characteristic, define, if I say define. It, the characteristic of a, this is a, it defines the shape of an orbit. Okay. But the E, you've asked me what E is, this is E. The ratio between this divided by major axis. Does that make sense? RA minus RP, what is RA? RA is this, right?
Yes.
RP is this. This distance is what?
R.
You understand? This distance is?
R.
Hmm?
2A.
Okay, this is it. Alright. So let's look at a few more things from this. Alright. If I say pay attention, perigee altitude. What information is embedded in that?
Can you say what is what?
What information is embedded in perigee altitude?
That'd be D.
What information is embedded in perigee altitude?
Is that semi-minor?
Hmm?
That's semi-minor? Or is it
RP?
the,
RP, but what information is embedded?
What do you mean by
The altitude.
So you have
Altitude.
you have the type of orbit.
Huh? Orbit? What does it say about the orbit?
Oh, said the elliptical is focused on what Earth is the focus.
It's an Earth orbit. Does that make sense? So if I give you all of this and I don't specify what the central body is, are you going to panic?
No, we shouldn't.
Perigee means G means geo.
Yo.
You get it?
Mhm.
So I might say the perigee altitude and the apogee altitude is this. You cannot ask me what is the central body. You cannot ask me what the radius is, which radius you are going to take. Which radius are you going to take? Here? Earth radius. Because this is perigee. If I say this is a perihelion altitude, you're going to take this as
You're supposed to memorize Earth's radius?
Huh? No, I'll give you the values. You don't have to memorize those values. I'll give you the values, but you should know these nomenclature. That's the reason nomenclature is important. There will be questions on nomenclature.
Wait, what's the nomenclature for Sun and Earth? Like, you have RE for, I mean, for Sun and Moon, you have RE for Earth.
Yeah, you have, this is for Earth, this is for Sun.
Oh, so there's no letters, not no R.
Don't worry about this. This will be made pretty clear to you. I don't expect you to know things out of the blue. Something like this. But this we have several times talked about perigee, apogee, right? I've talked about periapsis, apoapsis, how they are the general terms. I've talked about perigee, apogee, perihelion, apohelion. Mu would be, if you take this becomes perihelion, mu would be relating to sun. Okay, so the table will relate to sun.
Listen, question. If you ask like what is mu, and we say it's a constant, is that considered wrong?
Yeah, you won't get points for that. What else is constant?
H, N,
What else is constant?
C.
You can come up with infinite constants, right?
Okay.
That's the characteristic of it. And when I say nomenclature, what is your nomenclature?
Like
I talked about this. What is your nomenclature?
Julian.
Julian Thomson, right? So that particular name. If I say Julian Thomson is a aerospace, if you say, I say Julian Thomson, you say aerospace, right?
Yeah.
Aerospace senior. You see? Alright, so eccentricity, you can calculate eccentricity of this.
Oh.
Of this.
You just
Michael?
guys.
Michael,
So that's the 4,000 square root of.
if you are given this information, I'm asking, okay?
Well, no, you can't. I mean, you can be close to it, but you still have to add it plus RE.
Mm-hmm.
Okay? Taurus, this information, can you calculate eccentricity?
Yeah, you just add the radius of the Earth to each one.
Yeah.
One that's your RA and RP.
Okay.
And you say you do what?
Angular momentum h.
Oh yeah, you just add 400 to the radius of the Earth, and that gives you your RP. And for RA, you add 4,000 to the radius of the Earth.
Here is another important question. If you have been studying, how do you find h?
Like that is,
Listen to me carefully here, okay? Whenever you are asked to calculate h, guys, pay attention here. Don't write anything. You know this, right?
yeah.
You see, we have talked about this, at perigee, at apogee, V perpendicular is simply the velocity. The radial component is 0. Okay? This is for an elliptical orbit. It holds true for circular orbits as well, but for circular orbits, V perpendicular is always V. Okay? Here, once you calculate this, do you know this? What is this?
That's the
400 plus.
400 plus RE. How do you find VP? VV.
Oh, V.
When the B's
Hmm?
the B's being equation.
Can you use this View equation?
We can use R, we can just put a mu over R to find V. Go back and plug that in, right?
View
Yeah.
over?
I said we can find the square root of mu over R and then use that value for V.
Correct. Yes. Can you do that?
See if I can.
So Julian says he wants to use this. Would you allow him to use this?
Nah, this is a circle.
Yes.
Should,
It's only for circles.
Oh,
But in here they use RP equals A squared over mu times 1 over 1 plus E. So are you going that route or are you going
You can use, so you should know how to go about this, okay? So whatever formula they are using there, if you don't have that formula, you're going to start with, guys, pay attention here. You know this, right? What is this also equal to?
0.
for
Isn't it?
Stand up, Anthony. You're sleeping.
No, isn't epsilon equals 0?
Is it?
no.
Or is that just
Only in
a
situation. Only in a certain situation.
Bro, that's the
First, no problem.
It's for a parabola, okay? So Anthony has made a mistake and you should all learn from that. Epsilon is 0 for what case?
very well.
Parabolic.
Okay.
Does that make sense?
Yeah.
What orbit is this?
Elliptical.
Elliptical orbit. Are you going to, what is the punishment if you say this is a parabolic orbit?
0.
0.
You'll be put in a parabolic orbit. You will never return. You know this as well, right? We have derived this. So you use this part of the equation. Got it? And then you can arrive at that. So here we know this is RP, right? If this is RP, this becomes B. You get it? And you get V is equal to minus mu over 2A minus plus mu over RP. And And if you simplify this, you're going to get b square is equal to
2 times -2.
so b square over 2 rp. Okay. You don't have to simplify it. You can simply use this. What do you know here?
You know, you know, RP,
Hmm?
you know,
I think
You-
didn't it just plug in the value for A to get to that equation?
Do you know A?
Oh, I'm saying is it in
Yeah,
alternate
you
form,
can
maybe. Alternate form, maybe.
You want this? You want to use this? A square over mu.
Yeah, is that not what they did?
This one?
Yeah, is that not what they did to arrive at the equation in the book?
Right. So you can use this as well. Okay. Here, what is known?
everything.
How do you calculate A? How do you calculate A, guys? A is very simple. So here, what is known? If you use this formula, what is being asked? You are being asked to calculate age, right?
Right.
How do you calculate? First, you need to calculate what is known here. What have you calculated until this point? You know mu, right? You calculated E here. How do you calculate A?
H was R divided by 2.
Yes. You do that, you get A. You get a value for age. That age will be all these ages. What you should always remember is, and this we have talked about, age will be constant anywhere you calculate it. You get it? So what you do is, you go to the periapsis or apoapsis, where V perpendicular is simply the velocity. Calculate age, okay, and use it anywhere you want to calculate V perpendicular for any other point.
Okay, confused about two things. That I think just kind of got lost in. I'm confused about what you use to calculate V and what you use to calculate H.
So you're really being asked H, okay. If you remember, if you note down this formula in your formula sheet, you can calculate age from this, knowing A is do you know this? Do you know this? You get A, you substitute A here, you know this mu, you can get age. You get it?
For mu, he said,
And then once you get H, then you get V.
You not asked, V is not being asked.
Okay, I don't know, this conversation started with you guys and how do you
If V is asked, you can calculate, you can back calculate, you can use H from here to calculate V.
Okay.
Okay.
actually,
Hmm.
we would use the mu for Earth.
That will be given to you.
Okay.
Okay. All the constants will be given to you. You don't have to worry about it.
Can you say one more time how we can get H from having that same equation A, RP plus RA? Like, what do we know?
You know this, right?
Yeah.
You can get A.
Yeah.
You put it here.
Oh, okay. Got you.
Perigee velocity. So this is what I was getting to. Perigee velocity is Vp, right? Got it? That's the reason I'm saying H is very critical. You should know this. Unless you know this, you won't be able to get to this. Apogee velocity. VA is H over R. Okay? Semi-major axis. We've already calculated that. Period of the orbit. Can you calculate the period of the orbit? Simple, right? Straightforward substitution.
Repeat
Period of the orbit.
There we go with it.
What is the formula?
Oh.
Don't make me go over the form. You figure out. You think about it. We've already gone over it. You tell me how to do it. How do you calculate the period? Curious.
Calculate period, T equal
2 pi
2 pi
over.
mu times A.
It's not T squared.
Yeah.
It's T squared.
The square root would be.
Whatever. Either form. Either way.
I can write it down for you, Dr.
I'm-
Sunday. Josh was interrupting me.
I was helping him. He forgot the square root. That's -1.
Oh, you told me about it.
Yeah, we got to do a process.
Okay.
You can have this.
See, you have to do this. The whole point is I want you to think. I think you're missing this whole education aspect. I don't want you to tell, okay, this is, you keep on asking me. One of the questions Hunter asked me was, can you specifically tell us what is going to be on exam? I don't want to specifically tell you what is on exam. It is not about exam. You understand?
It's about understanding what we're feeling.
So it is not about exam, right?
It's about
It is understanding the
concept
the material, right? The concepts. So I cannot prepare you for using the formulas. Do you want me to prepare how to use which are the formulas which will come in the exam, how to substitute, how to press the calculator button? That is what you want me to prepare? That is what you
It's teamwork. So working a team, I always used to.
I don't want to prepare you like that. Okay? That is not, you're paying a lot of money to come here and get an education. I need you to learn how to think, how to apply what you have learned. Guys, have a seat, don't leave yet. Just have a seat.
That'll work.
Alright, E,
And I got walk.
so you can calculate A, right?
That's why you line.
Can you calculate P? Yes? You can, right? Can you calculate true anomaly when R is equal to?
I think that's the same. Which is just
Dr. Sun, what is that E on the board?
It's A.
Just A.
Right. Okay. So simply. So the last one is this true anomaly. Okay. If I say calculate true anomaly at perigee, what are you going to say?
Zero degrees.
So you're not going to go calculate that.
Say 0 degrees, right?
You're going to say 0 degrees. If you are learning to think, you'll just say 0 degrees. If you are used to using calculators, you're going to press a whole lot of numbers to go nowhere.
waste time and lose points.
How do you want us to explain that? Like, when you just write
If I only say explain it. Otherwise, don't explain. If it's like this, you should kind of get it, this thing that it's just one point. So for example, here I say calculate, right? You write the formula and then show the calculation. Here, if there is nothing to calculate, for example, there was a problem on the first test. What is the projection of the perpendicular to a plane on that plane?
It's gonna be with,
I don't understand your question.
What is the projection of a perpendicular to a plane on that plane?
Isn't it zero?
Zero. So there were two lines, right? You guys remember? Many of you did the calculations, and here is a classic example of why you should know where to use calculator. I gave you two lines, two vectors, remember?
Right.
And I told you there's a perpendicular, right? A and B.
Right.
This is perpendicular,
Right.
right? And then you were supposed to what is the projection of this on this?
90? Is it 90?
It'll be zero because you can't see that.
Projection is essentially, think about this. What is the projection of this on this?
Zero.
If there is a light falling on this, projection of this on this will be
Oh, zero.
0. When the angle is 90 degrees, the projection is 0. So you did a whole lot of calculations to figure out that nobody really wrote an answer 0 there. Even Torius wrote an answer very, very small decimal number. Because you use the calculator.
Calculator.
You can't.
Calculators cannot be smarter than you. Then you are going to be out of job.
I mean,
You should say 0.
I want to make sure Dr. Sunday.
But then you should go back and say it's 0. If you just leave that point, then I know
I
you're.
left that right there.
Huh?
I thought I left that right there.
You did not say 0.
Oh, I didn't say that. I should have. I forgot.
Can't take it back.
Alright, I'll see you guys tomorrow.